So question 3 here, we are given is a partial plan of a regular tetrahedron. Complete the projections of the solid, draw the inscribed and circumscribed spheres. Okay, so we just have to draw out the projections, which is plan, elevation, end view first. So same as question 2, we just bisect our angles to find the center to give us our apex. Okay, we can bisect two angles. If we bisect the third one, it should give us the same point. So if you want to double check, bisect the three of them, there's no problem. Construction lines then, through the bisector. Where they intersect, here, should give you the apex. So that point there, we'll go straight back. We know down, when we're looking down at it, it's going to be an edge. So it's going to be heavy detail, solid lines.
For interrupting classes, I've just one announcement, and Tom Common Gaelic, it trust neuro Arash and you, Common Gaelic will start back today, it's shown we're Kuitake, it can on loan, so in room 15 at lunchtime, and Mr. Brannock and his team will be there to greet any students, first years included, who would like to go along to our Irish club at lunchtime today, Tuesday. And you can chance a couple of focal with Mr. Brannock at 12:30 today in room 15, Gormil Magriff.
Okay, sorry about the interruption. So we're going to come across then 45 degrees, bring all our points across, our apex point, our AC, all our points across and up. So our apex then, same again, we don't know where it is. We know it's on that line somewhere, but we don't know what height off the ground. But we know A and C sit here, and we know that B sits here also. So we need to do the same thing as the last question. So when we're looking in here again at 90 degrees, we see BO as a true length. Okay, so BO is true length, so the true length of that we can see is in plan. BC should be the same as the true length of BO. So we have to swing from B to the crosses there, apex point, and that gives us O. So we can join B back to O, the apex, and AC back to our apex. Okay, so that's our plan completed, that's our end view completed. We have our height in our end elevation, so we bring it across to our elevation. So we know that is the apex, so we can join C back to O, we can join A back to the apex, O, and then we know B to O is going to be at the front, so we'll see the edge. So it's not hidden detail, so we have it in. So that's plan, elevation, end view done. So that's complete the projections. That's done. Next thing we need to draw an inscribed and circumscribed sphere. So first thing we do is inscribed. So if we look down, if we put a sphere inside tetrahedron, it has to touch each face of the tetrahedron in the dead center. Okay, so somewhere along here. So we know that every face is touched in the center. So if we bisect the angle, it should find the center point. Okay, so if we look straight down, we know this is the center point now of our sphere, but we don't know how large it is. So we have to figure out how to find that. But we know that the center point is on our apex line somewhere. It's because it's directly below our apex. So how do we find it? Okay, we find it by straight below. We find it by bisecting one angle up here. So if we bisect angle AC and bring it across, so bisect angle AC and bring it across, where it intersects our imaginary line underneath, or our center line, okay, of our tetrahedron. That should give you the center point of your circle. So the radius, we know it has to touch the face. There's a face on the bottom of the surface. So from here to here should be our radius. So if we swing a sphere, we can see the 2 points of contact that it has along here. It's touching the surface here and it's touching the surface there. So we have our center point and we have our radius set up. So keep your radius set up on the compass. We know it's here in plan, the center point, so we can just swing it. So that's our sphere, inscribed. So next thing we need to do is, we know it's underneath the apex somewhere. Okay, so we can just bring it across our center point. Where it crosses there will give you your center point. And then we need to swing our radius to give us our sphere. So that's the first part done. Perfect. So we know circumscribed sphere is also a sphere, but it's going to be touching. If we drew a sphere around here, it's going to touch each corner, okay, but not in every view. It won't appear like it touches every corner in every view. Okay, so what we need to do now is figure out where the center point is and the radius of our sphere. That's going to be circumscribed. So we know our center point has to be the same. Okay, so our center point has to be the same. So we know that the apex is going to touch it. We can see the apex here. So we know our radius has to be from our center point to our apex. That is the radius of sphere 2. It should also touch, because it's a true length, because this is a true length, it will touch edge, or sorry, apex B. So now we have our center point, we have our radius, so we can draw it in every view. Okay, so to touch our apex in our both elevations, it should only touch B in our end view, and it should appear like it touches no points in our plan. Okay, so it should just miss them.